Okay, we start with objective question. Are you guys ready to start? Boleh mula?
Yes,
Yes, sir.
sir.
Alright, good.
Yes, sir.
Okay, a body of mass m slides a distance d along a horizontal surface. What is the work done by the gravity?
0.
0, okay. So if you want to imagine this thing, maybe I can try to draw it out for you. So you have a body of mass m. So this is the body. It slides along the horizontal surface. So maybe in this direction, S. Okay, then the question asks you what is the work done by the gravity. So obviously you have the work done by the gravity is due to the weight. So the weight is actually in that direction. So if I want to use my formula, I have to substitute W. Okay. So the W here means the weight. The first W is the work, as cos theta. And you can see clearly from this diagram, the angle between the force and the displacement would be berapa degree?
90.
Yes.
90.
Since theta is equals to 90 degrees, so the whole terms here become 0. So the answer would be B. Okay, good, very good. Okay, when the force is applied on an object, but object does not move, it means that apa?
Your work is done.
Okay,
No
the
work is done.
okay. Same thing over here. If we use the same formula, work equals to F S cos theta. When the object does not move, so it means that the S is equals to 0. So regardless of the force being applied, once this one is 0, everything else is 0. So that means the answer will be B. No work is done. Okay. Question number 3. An object that has a potential energy has this energy because of its apa?
Position.
Yes. It depends. This one actually comes from the definition lah. Potential energy depends on position. Even with the elastic potential, it depends on the position. Means that where it is stretched, compressed. The question number 4. The speed of an object is double. Its kinetic energy is therefore apa jawapan dia? Donkey.
Jawapan dia D, tapi saya jawab B. Kenapa D, sir?
Okay.
Quadrate.
Okay, we can try to do this. Okay. Let's say if I do it over here. Question number 4. Okay, so to solve or to show this one, sometimes in exam PSPM, they ask you to show your working for this kind of situation. Like they give you what happened when the velocity increase, what happened when the mass increase. It could be any question or any formula, but for this one, it's kinetic energy. So kinetic energy equals to half mv squared. Okay, so K here represent the initial. The V here represent the initial. So before it has any changes lah. But now dia kata the speed of an object is double. Okay. So you have a new kinetic energy. I put that one as my K prime. New energy. So I have half m, and now I have a new velocity. I put that one as V prime. So the prime indicates the new one. Okay. So the relation between prime and V is that the prime equals to 2V. Okay, so this one from the statement from the question lah. It means that the velocity is now double. Okay, twice the values of initial one. So K prime, I just substitute back, equals to half m. I will have 2V squared. Okay, so I can take out the brackets. So I got 2 square over there. So I got 4, and then I just leave everything as it is. Okay. So here you can see that if we are looking at this term, it is actually exactly the same with this one. Okay, which is this one lah. So I can substitute back the k. Now my k prime is equals to 4k. So it means that this one now quadruple, 4 times the initial k. You guys understand or not?
Yes, sir. Faham?
Yes sir, faham.
Yes.
This technique is very important. Okay, you can apply it across any formula, any chapter. So basically what you did, what you need to do is that you just replace, like this one, for a new quantity, you put a prime, okay, and then you just write down the relation. Then you try to substitute back, but you don't have to solve anything. You just have to move around so that you still have this term. Okay, so this term is actually the same with this one, so that you can replace with the k, so that it can relates back to the initial. So sometimes they might ask in the exam. Okay, for the last question, question 5, for objective question, what are the units of power?
D.
D.
Yes, the answer is donkey. So you know that watt is obviously the SI unit. That is correct. Joule per second comes from the formula, okay, delta T, delta E. So that one's joule per second. Horsepower, actually this one also in terms of power. Except that most of the time they use this one maybe for the engines. Okay. Okay, moving on to the next one. Oops. Question number 6. A boy pushes a box with a constant net force of 180 Newton. Okay, I zoom in a little bit. At an angle of 30 degrees with the horizontal. How much work is done if the box is pushed through a distance of 50 meters? Okay, so it looks easy, it seems easy, but no harm if you try to draw it out. So try to draw it out. So question A, a boy pushes a box with a constant net force of 180 at an angle of 30 degrees. Okay. So I have a horizontal surface. The force is 30 degrees to the horizontal. So the distance will be 50 meters. So S is equals to 50 meters. I think this one is straightforward because they give you the F and they ask you to calculate how much work done by the F itself. So you can calculate work done by F equals to F S cos theta. You just have to substitute all the values. 80, 15, cos 30 degrees. Okay, the angle is between F and S. So your S is in this direction. So 30 degree. So berapa ni dapat ni? How much you get for this one?
2338.
2338.29.
2338.27. Is it?
Yeah.
Yeah.
Good. Okay, the unit will be joule. Jangan lupa tulis joule. Okay, the next question. Okay, question B. A 3 kilogram box is lifted vertically from rest to a distance of 2 meters with a constant upward applied force of 60 Newton. Okay, calculate the work done by the applied force and the work done by the gravity. So this is my box. Okay. If I want to draw the free body diagram over the diagram itself, so I'll have a force that is pulling it upwards and a force that is pulling it downwards. Okay. The force that is pulling it upward is actually your applied force. So put F. Okay. And this one is your weight. Okay, question number 1, they ask you to find the work done by the gravity. Travel 2 meters. Okay, S will be in this direction. Okay, if I want to use the formula, I can use would for F is equals to F S cos theta. The force is 60. The displacement is 2. The theta is equals to
0.
0. Kenapa?
Sebab
Sebab
kosong.
Sebab F dengan
Dia-
S dia sama arah.
Yes. Okay. Because F and S is in the same direction. So this one outwards, this one outwards. So the angle between them is 0 lah. So that one becomes 1. Cos 0 is equals to 1. So we got 120 joule. Betul ke salah? Betul eh?
betul sir.
Okay, that one is for question 1. For question 2, the work done by the gravity. So the work done by gravity is actually due to the force of the weight. So work done by the weight is equals to weight as cos theta. Okay, the weight is equals to mg. So 3, 9.81. Maybe I don't skip. Equals to mg as cos. Okay, cos berapa degree ni? What's the angle between weight and S?
180.
Yes. Okay. You can see that the S is pointing upwards. So if I draw it over here, it's pointing upwards, while the weight is pointing downwards. So the angle between these two is basically 180 degrees. Okay. So 180 cos 180 would be -1. So you have -6 multiplied by 9.1. -58.86. Is it correct?
Yes sir.
Okay, good. Okay, so that one's for question 6. Any question so far? No, eh?
No,
Okay, moving on to the next one. 6 done. Let's look at question 7. 7 boleh jawab?
7B saya tak boleh.
Okay. It's okay, we discuss together. Okay, a tourist drags his luggage of mass 20 kg with a force F at a constant velocity. Okay. Mass is 20 kg. Constant velocity across the floor as shown in figure 5.1. The coefficient of kinetic friction between the rollers of the luggage and the floor is 0.4. The luggage is dragged 0.8 meter along the floor. Okay. Calculate the work done by the luggage by the normal force and then by the force F. First of all, maybe you can write down all the information. So the mass is given. Okay. And look at constant velocity. Constant velocity means what? What does it mean by constant velocity?
Zero acceleration.
Okay, very good. Acceleration is equals to 0. So does this object is at equilibrium? Adakah dia dekat equilibrium?
Ya.
Yes. Okay. So when you have E equals to 0, that means it's at equilibrium. Mu K is equals to 0.4. There's no unit for mu K. S is equals to 0.8 meter. Okay, double check the unit. Always double check the unit. Make sure you use the SI unit. Okay, question number A, they want to find the work done on the luggage by a normal force. By the normal force. So maybe you can try to draw the free body diagram first. I will draw it over here. And bring it a bit up. Okay, how many forces are there? Ada F, kan? This one. Lagi apa?
FP and W
And ke mana? Ke atas.
ni ke atas.
Okay.
Lepas tu ada F key.
Ada apa?
F key.
Okay, FK ke kiri, betul?
Bawah.
Betul salah? Okay. So yang ke bawah tu first apa? Tengok. Pergi. Okay, yang downwards ni adalah weight, betul? Atas ni adalah, and to the left is actually your friction. Okay? You guys okay with this?
Okay, sir.
Okay. So, jangan confuse N ni, right? It depends on the surface. It's 90 degree to the surface. Okay, regardless of the position of the object, it's always 90 degree to the surface. So, you have a horizontal surface, it's 90 degrees, it's like that. Okay, if the surface is slanted like that, then your N will be in that direction. Okay, jangan confuse. Okay, so you have force, that direction. And weight, force, Fk. You have the angle over there, which is equals to 37. Okay, so far, any question regarding the FBD? Did you guys get the same FBD or you guys get the different one? Sama tak dengan saya punya?
Sama sir, sama.
Same.
Okay. Now, you don't have the A, but you do know the direction of S. So, S dia ke mana?
Ke kanan.
Kanan, eh? So, this same, almost similar with the chapter 4. Okay, where the motion of the object will be on one of the axis. Okay, so maksud saya, this will be your x-axis and this will be your y-axis. So looking at these two axes, katakan saya ada axis x and axis y, force mana yang bukan dekat atas axis ni?
F.
F. So F is actually dia dekat in between x dengan y lah. So if it is in between x dengan y, kamu kena buat apa?
Resolve.
Yes,
Resolve.
very good. So you have to resolve that one. So I'm going to resolve it into fx and fy. Okay. So once you resolve, basically you can basically ignore lah benda ni. Dia dah tak ada lah. Dia tinggal itu je force. Tapi saya biar juga senang. Okay, now you can solve this one. Okay, soalan A. Saya tak tahu baca soalan ni. Soalan dia apa nak? The work done on the luggage by the normal force. Okay, soalan A dia. Kita buat soalan A. Okay, so question way to find the work done on the luggage by the normal force. So if you want to find this one as your N, you need to substitute F as your N as cos theta. Okay, what is the angle between N and S?
90.
Okay, 90 degrees. Okay, and S cos 90. Okay, for those who couldn't see, this one N is pointing upwards and your S is in this direction. Okay, it moves to the right. So the angle between N and S is 90 degrees. When you press your calculator, cos 90 is equals to 0. Okay, good. Very good. So the answer will be 0 joule. So that one's for question A.
Sir, kalau soalan macam ni kita tak perlu nak tunjukkan kita cari N semua.
Tak perlu.
Oh, boleh terus straight je lah masuk dalam formula.
Betul?
See. Okay.
So biasa markah dia pun maybe 2 je kot. Macam tu. Okay. For question B, they want to find the work done on the luggage by the force F. So obviously, if you want to find the work done by the luggage F, on the luggage by F, you have to use values of F. F as cos theta. The problem here is that you don't have the values of F. It's not given, so you have to calculate. So the key thing here, the reason why you can calculate is because the A is equals to 0. Or if they give you A, then you can calculate lah. So in this case, I can do the equation like summation of fx equals to 0 and summation of fy equals to 0. You might need to use the fy, you might not need to use the fy. You just do it by side, so that whenever you stop, you can always go to the other side. Sekejap fx, sekejap fy, macam tu lah. Okay, now for fx, I have fx minus ft equals to 0. Okay, kalau dia equals to 0, you choose right minus left. Upwards minus downwards. If it is equals to MA, normally I would suggest my student to use same direction with A minus opposite direction with A. Okay, that one different question you might came across with that. I think dekat tutorial question ada yang chapter 4, so I point it out. So I point it out again over here. Kalau later kita jumpa lagi, kita discuss lagi. Faham tak maksud saya? A tu dia yang ikut A minus opposite A. You guys understand or not? Tak? Yes? No?
Faham.
Faham
Ada soalan tu.
Ada soalan Okay, contoh yang saya katakan, contoh dia kata ada A, dia kata ada A, acceleration ada ke kiri contohnya. So if in that case, this one you have to equate with MA. So this one you do FK minus FX. Okay, yang sama direction minus opposite direction. Okay, that one we keep that one first lah. Tak ada pun kat sini. So for Fy, ada berapa banyak force dekat Y axis? Over here this is the Y axis. Just now is the X axis. Always double check. So we have 2 force. So ada 2 force. Okay lah. Y axis ada berapa banyak force?
Ada 3.
Yes, ada 3. So it will be N plus Fy minus weight equals to 0. Okay, you guys agree with this? Okay with this?
Yes.
Agreed.
Okay, any questions so far?
No sir.
No, sir.
Okay, since the question wanting to find work for F, you need to find F. So you can open out the F over here. Okay, I suspect because they did give you the mu. Okay, so somehow you might have to use it. So the mu comes from inside here. So I will open up this one into a formula lah. So it will be F. It will be cos 37. Okay, it comes from in this one lah. Fx over here, if you want to resolve from the F, you go through the angle, so it will be cos. So I bring the Fk to the right hand side, and then I write down the formula for Fk, which is mu k, and I do have the mu k. If I want to find my F, now I need to have my N. Okay, you can get the N from the Fy, where N is equals to Fy weight. I bring the weight to the right hand side. Weight is positive. Might have to do it this side a little bit. Minus the Fy, which is F sine 37 degree. So far so good? I guess okay?
Yes sir.
Yes, sir.
This one is equation 1, this one is equation 2. So I can substitute my equation 2 instead equation 1. Okay, for my equation 2, I do have my mg. So I have my mg already, but I still don't have the f. So if I substitute, maybe I can solve. So dah, saya lupa sini buat apa. Okay, substitute 2 into 1. Okay, maybe you can press your calculator for that one. Tapi saya biar dulu lah. Kita panjang sangat. So cukup 0.4. The new k is 0.4. The n now becomes mg minus f sine 37 degree. Okay, so I can try to solve this one. Cos 37 is equals to 0.799. Okay, this one is 0.4 multiplied with the mass, which is equals to 20. Sine 37 is equals to 0.602. Okay, make sure to round it off. Okay, but then because this one ada 0.4, I open up the bracket, so it's multiplied with that one. So it will be 0.4 okay. So now I can solve this one. I can bring it to the left hand side. So 0.4 multiplied 0.602 plus 0.799. I got 1.04. Okay, that one 0.4 times 20 times 9.81. 78.48. I got here is 75.46. Okay, this one is question 7. Okay, that one is for the force. You haven't finished yet. You still have to find the work. Okay, so far okay ke tidak?
Okay.
Okay, sir.
Okay. Mana saya nak buat? Okay, I try to do it on a new page. Or maybe saya kecilkan sikit kot. Okay, small a bit. Okay. Now, if I want to find my work F, which is F as cos theta, I substitute back 75.46. S is 0.8. Okay, and then this one will be cos. Okay, angle dia berapa? 37. Okay, just have to look back at your diagram over here lah. So the angle between F and S is 37 degrees. Take your calculator, 75.46 10.8 times cos 37. You should get 48.21. Okay, so I will give you 1 minute to digest kejap apa yang saya buat. Okay, jadi kita discuss.
Sir.
Ah.
Yang F sama dengan 75.4 N tu datang mana?
This one.
Ah.
Okay, this one unit dia. Newton.
Apa?
Unit Newton.
Oh, Newton.
Unit force.
Okay.
Okay.
Saya ingat N tu apa?
Normal. Okay, ingat normal. Okay.
Ah.
Okay, kalau yang before this kamu try, I think most of you guys ada ramai tak dapat. I think maybe because of this one. Betul ke?
Betul, sir, betul.
Okay.
Waktu nak tahu nak guna nak letak first apa tu.
Sorry, apa?
Waktu kita nak tahu kita nak letak first apa untuk resolve ke tu.
Same. Okay. Tapi sekarang okay ke tak? Dah okay lah.
Dah nampak dah.
Alright. So in exam, you really need to draw the free body diagrams like this. Okay. So whenever you have a force that is not on the X or Y, like this one, you straight away draw Fy and Fx. Okay. Even saya pun selalu terlupa yang Fy ni. I don't know why. Memang selalu terlupa. And then once you did that, dia punya keberangkalian tertinggal tu berkurang lah. Most likely kalau tertinggal juga, maybe it's a minor mistake. Cuai, things like that. And then lagi satu N ni. Mana. Okay, this one. Okay, memang I think initially saya dulu lah, saya pun ada juga habit. Whenever I see N, I want to substitute this one with NG. Sebab memang dah biasa kat sekolah dulu, N equals to NG, N equals to NG. So now it's no longer equals to NG lah. So you have this one, the whole term. Okay. And macam-macam. Okay. And then lagi satu, bila kita tengok the flat surface, kita ingat the NG. Tapi bukan. Sebab apa? Sebab the force ni. Okay, anyway, with the free body diagram, you should be able to avoid those mistakes lah. And then even with the free body diagram, you really have to be careful and do it, just take your time, do it slowly, don't miss anything. Okay, the next question number 8. Okay, I think this one is conceptual question. The graph in figure 5.2 shows the magnitude of the force exerted by a given spring as a function of the distance. The spring is stretched. Okay, calculate the work done to stretch this spring. Okay. Question number 1, from A equals X equals to 0. From here to X equals to 5. So from there to there lah. So how do you want to calculate the work? Find the work.
Area under the graph.
Yes, okay. So for question A, 1, work is equals to area under the graph. Okay. And the area under the graph from 0 to 5 will be this one. Okay. So what I'm going to do, just want to draw it again. Okay. So this is basically just a triangle. The base here will be 5. The height there will be 250. Okay, but be careful because they give you in centimeter. So if you want to have your final answer to be in SI unit, you really need to write down the SI unit lah. So the displacement X, so it will be 0.05 meter. So in Newton, so it should be okay. So if I want to calculate work, which is area under the graph, it will be half multiplied with the base multiplied with the height. Okay. So now 0.5, 0.05, 250, 6.25, betul?
Betul.
Okay, for the next question, so the next question we want to find from X equals to 2 into X equals to 7. So from here to here. So you have two methods. One, you can calculate the bigger triangle and then you just minus the smaller one. Or you can straight away calculate the trapezium there. So I'm going to calculate the trapezium there, which is this one, this area. Okay. So again, for A2, work is basically area under the graph okay, and this time it is a trapezium, so I'm going to draw it out for you. Okay. So the base there, base is equals to 5. Again, 0.05. Okay. A is equals to 100. B is equals to 350. Okay. So the formula becomes half multiplied by itu adalah C half multiplied by C multiplied by A plus B. Kamu pakai trapezium ke pakai triangle juga tu?
Trapezium.
Trapezium.
Kalau dalam exam boleh ingat rumus trapezium.
InsyaAllah.
Ya, salah. So macam benda-benda ni dia tak kasih lah dalam formula. So you have to memorize it yourself. So the answer will be 11.25. Sama tak?
Sama sir.
Okay. That was straightforward. Okay, question B. Okay, this one question 8. Still question 8, but question 8B. Okay, so horizontal force is applied. Okay, car. The force varies with the displacement of the car. Calculate the work done by the force F when the car moves from 0 to 8. So from the start here until at the end there. So you still apply the same concept, which is work done is equals to area under the graph. Okay. But you have to be careful. If the area is below, like this one, below the horizontal, that one is considered as negative. If it is above, then the work done here is positive. Okay, so that means it will be positive work for A, on the other hand, negative work for B. Faham? Below horizontal is negative, above is positive. Okay, good. So to solve that one, basically you have two area. Lukis ke tak payahlah saya tak lukis. So it becomes area A minus with the area B. So if you calculate area, you wouldn't get the negative. Kamu tak akan dapat negative. So kamu kena letak sendiri lah negative tu. So for A is trapezium. So basically this is your A, this is your B, this is your C. So everything is in SI units. So it should be okay. So half A plus B. Okay, this one be careful a little bit. Kalau kamu tak sure, make sure kamu draw. Okay, maybe saya boleh draw code. Kamu confuse later on. Okay, so one of these is trapezium. Okay, and one of those is the triangle. And this one is your A. 5 minus 2, which is equals to 3. And down here B is equals to 6 meter. And the height is equals to 20. On the other hand, this one, height is equals to 10. And the base there is equals to 2. So I can solve this one. So formula 2, A plus B minus half 2 times 10. Betul ke tak ni?
Boleh.
Is it 80?
Yes.
Okay, good.
Yes.
Okay. That one's for question 8. So work done is basically the area under the graph. Be careful if you have the work done below the horizontal line, that one would be a negative area or negative work lah. So you just have to put the minus sign manually. So the negative tu actually means energy taken out from the system. Okay, kalau positive tu energy into the system. Okay, so now we're moving on to the next question. Then we can do one more question quick. Last one. Oops. We're going to do question number 9. Okay, figure 5.4 shows two objects with mass of 3 kg and 1 kg are connected by a light inextensible string. So string dia tak meregang lah. So takkan ada elastic potential, tak ada. String passes over a smooth pulley. Okay, the system is released from rest with the 1 kg mass on the ground and the 3 kg mass at the point 2 meter above the ground. Okay, calculate the change in potential energy of the system when the 3 kg mass reach the ground. Okay, this one, let's baca soalan dia tanya apa. So dia tak ada tanya pasal work, betul eh? So the question actually just asks to find the change in energy. Okay, interesting. So this one is most likely you have to use conservation of energy. Okay, release from rest. Okay, so initially velocity is equals to berapa?
0.
Yes. Okay. 2 meter above the ground. Okay. Calculate the change in gravitational potential energy of the system when the 3 kg mass reach the ground. Okay. So we have two mass. Let's say I put this one as M1 and M2. So initially this is the situation. Okay. Final, my 3 kilograms now on the ground. My 1 kilogram is up here. Okay, berapa tingginya?
2.
2. So dia turun 2, dia naik 2 lah. Takkanlah sebelah tu turun 2, sebelah lagi naik 3, pelik pula. Okay. Okay, soalan dia senang sangat. Saya ingatkan kita pakai conservation of energy, tak perlu pun. So, the question we have to find summation of U for initial and summation of U for final, so that you can find the difference. Okay, so delta U is basically U final minus U initial. So this is the idea lah. So you need to find I initial and final separately. To find initial, you assume that this one is our 0. Okay, assume this one is height equals to 0 as well lah. So that potential over there is 0. Okay, U initial, you have mgh plus mgh. Okay, but the object 2 is on the ground, so the height is equals to 0, right? So the whole term here is become 0. Okay, so you just have the 3, 9.81, and the height is equals to 2. Okay, on the other hand, for when it start at the final position, we have M1, G1, H1. G tak ada subscript. So this one is the one that becomes 0. So you just left with the second one, which is 1, 9.81, and 2. Okay, obviously you can try to calculate separately. Or you can calculate straight away together. So here I have 3 minus 1, which is 2. Okay. So, kalau tak nampak, cuba apa jawapan dia ni?
Negatif 30. Jawapan semua negatif
Saya salah
30.
terbalik, saya salah tolak. Sebab kamu cakap negatif. So dia mesti final tolak initial. So it will be 1 minus 3. So it will be negative 2 kat sini. Kan? So berapa ni? Negatif berapa tadi? Sorry.
39.24.